Hi everyone, welcome to Learn It All. Hi. So firstly I want to apologize every one of you that recently I haven't posted any video. Right, I was busy working on some other project. So the topic we're going to discuss today is the propulsion system. Right? Because one of my students, Ishwar, had asked me to discuss the difference between the two propulsion systems, which is scramjet and ramjet. Right? So this is the reason why I'm making this video, the propulsion system. So which is a part of space technology and as well as the missile technology. So the missiles are also moved based on the same principles and based on the same technology, the propulsion technology. So we'll be discussing about that, the missile technology part in the next class. But today we're going to discuss the concepts of space technology and the concepts of propulsion system, right? So this is the topic here today, and about this learn it all. So I will be discussing the concepts of UPSC, APPSC, or any other competitive examination specifically to the subjects which I usually deal with. And about me, so this is me, Ashok. So I did my masters from IIT Kharagpur. So since the past 5 years, I have been the faculty of Science and Technology, Ecology, and International Relations. I also deal anthropology optional, and I wrote two books. And don't purchase the Science and Technology book for now because I'm upgrading that. I'm updating the information, and also the environmental ecology is yet to be published. So immediately after the lockdown, thank you for Narendra Modi ji. So by sometime the lockdown will be called off. So you can expect a book anytime soon, right? So and also have three international publications. So the topic today is the propulsion system. So we'll get into the topic. The propulsion system. So before I start any class, right, so the first thing I do is write the term. So only unless we know the meaning of the term, we cannot go into the deeper concepts. So the very first thing we're going to learn here today is learn the meaning of the propulsion, right? So what does this term mean, right? The word is derived from two Latin words, propeller, right? So propeller, right? So what do you mean with this propeller? So pro means before or forwards, right? That means it has to move something forward, pro, right? And propeller means to drive. That means there is something which is driving the movement, or there is something which is actually making the object move forward, right? This is the meaning of the word propeller. So the propulsion was derived from the word propeller, right? The propulsion means to push forward or drive an object forward. So this is the meaning of the word. So why we are studying this in the space technology? If at all you want to move some particular object, so obviously you have to propel that, you have to make it move forward. So for that particular purpose, what technologies are we employing to make a particular object move is nothing but the propulsion system, right? A propulsion system is a machine that produces thrust to push an object forward. So what do you mean by this propulsion system? It is nothing but a machine, right? So if at all you want to know the meaning of machine, the better watch Three Idiots movie, right? The American has actually given a really good definition of the word machine, right? A propulsion system is a machine that produces thrust to push an object forward. So this is the meaning of the propulsion system, or the meaning of the word propeller, or the meaning of the word propulsion, right? So since we are familiar with the meaning of the terms, we'll get into the deeper concepts. So what does this propulsion system work on? On what principle does this particular propulsion system work on? This is the other thing which we have to understand. So to understand, so here we are talking about moving forward. So if at all there is something has to move, so obviously we know the laws of motion, right? If at all you want to make some object move in a particular fashion, so obviously it has to follow the a few laws. So who is the person who has given us the laws? So obviously the Newton's three laws. We are very familiar with the third law, but not so familiar with the first and the second law, right? So here in the space technology, so we are sending the launch vehicles, or we are sending the rockets, we are sending the jets, right? We are sending the planes. So based on this Newton's laws. So how does this Newton's laws work on the propulsion system? So how the propulsion system works using the principles of the Newtonian laws, right? This is what we have to know, right? So the very first law. So the first law usually states that every object tends to be in the constant motion or in the constant rest until or unless external force is applied on it. So this is the Newton's first law, right? So Newton's first law states that every object continues to be in the state of uniform motion or in the state of rest until or unless external force is applied on that particular object. So if at all you want to move an object from the state of rest, you have to apply some force. If at all you want to stop a particular moving object, so obviously you have to apply a force. If at all you want to accelerate a particular object which is moving at a uniform velocity, you have to apply a force, right? So obviously the force matters the most, right? So in the first law, first, the thrust from the propulsion system must balance the drag of the airplane when the airplane is cruising, right? So what does this mean? So when you talk about the propulsion system, so obviously the propulsion system is actually present so that it is making a particular object move, right? So for a particular object to move in air, for a particular object to move in air, so obviously there is some force which is acting against the movement of that particular object. So there is a force which is actually pulling it, right? Instead of making it moving forward. So obviously we call it drag force, right? We call it drag force. So the thrust from the propulsion system must balance the drag of the airplane when the airplane is cruising. So if at all you want to move an airplane at a uniform velocity, so obviously, so the forward force must equal to the backward force, right? To make a plane move. And second, the thrust from the propulsion system must exceed the drag of the airplane for the airplane to accelerate. So the next one. So for an airplane to accelerate, so what do you mean by acceleration? Increasing the velocity of a particular thing, right? So if at all you want to accelerate, if at all you want to make it move faster, so you have to apply the thrust, you have to apply the force which must exceed the drag force, which must exceed the drag force. If at all the drag force and the thrust which you are giving is equal, so obviously it will cruise, right? If at all you are giving a force more than that of the drag force, obviously it will accelerate, right? In fact, the greater the difference between the thrust and the drag, called the excess thrust, the faster the airplane will accelerate. So the thrust which you give, if at all it is more than that of the drag force, obviously it will accelerate at a faster rate. That means the plane will actually move at a very faster rate. So this is the Newtonian law. So based on the first law, so obviously here we have the two forces, the drag force and the thrust which are actually giving, which you are actually giving to make a plane move forward or to make a particular object move forward. So if the drag force equals the thrust which you are giving, so obviously it will cruise. So if at all the drag force is very less than the force which you are usually giving, so obviously it will accelerate. If the difference between the drag force and the thrust you are giving is maximum, so obviously it will be accelerated at a very faster rate. So this is the first law. So every object tends to be in the constant rest or in the constant motion, right? Uniform motion until or unless external force is applied on it. So the external force which is being applied is the thrust, right? So the thrust is being generated by the propulsion system, right? The thrust is generated by the propulsion system. So this is the Newton first law. So what is the second law? Right? The second law states that the acceleration of an object. So what of the acceleration which you have produced over here, right? That acceleration of an object as produced by the net force. So you're providing the thrust. The thrust is being provided by the propulsion system. So object by a net force is directly proportional to the magnitude of the net force. Directly proportional to the magnitude of the net force. Directly proportional to the magnitude of the net force, right? That is the Newton's second law. The acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of an object. So obviously it is literally stating in simple terms, which we remember is F is equal to ma, right? So whatever the acceleration is directly proportional to the force and inversely proportional to the mass, F by m, right? So this is what the second law states, how much acceleration which you give. So obviously it is directly proportional to the force you are applying, right? Directly proportional to the magnitude of the net force in the same direction as the net force. So obviously it has to be in the same direction as the net force and inversely proportional to the mass of an object, right? This is the second law. So if at all you want to accelerate more, so obviously you have to increase the force more and you have to decrease the weight, you have to decrease the mass of a particular object as well, right, for an object to move forward. So why the mass matters the most, we'll see in the next classes, right? So the next one, third law, right? The third law states that for every action there is equal and opposite reaction. So which we remember very, it is a very familiar definition, right? The different propulsion systems develop thrust in different ways, but all thrust is generated to some applications of the Newtonian third law of motion, right? So obviously there are different propulsion systems which actually develop the thrust in different ways. So obviously we have the different propulsion system like the propeller, which is very basic thing, right? So we have the scramjet, we have the ramjet, right? We have the turbojet. These are the four basic propulsion systems. So when you take the application of this propulsion system, it is totally different. So they work on the different principles, but one of the basic principles in which they all work is the Newtonian third law, right? Third law of the Newton. So when it states that for every action there is equal and opposite reaction. So that means if at all you want to move a particular object forward, so obviously you give a particular action so that the reaction will be the movement forward, right? That has to be the reaction. When whatever the action which you are providing, so obviously against that particular action, the obviously our plane has to move forward, that has to be the reaction. So based on this particular principle, all the propulsion systems work. The next one, the four principal propulsion systems is nothing but the propeller, which we already discussed, the turbine, right, turbojet, turbines, right, the ramjet, right, and the rocket, ramjet and the rocket, right, the propeller, turbine, ramjet and the rocket. These are the four principal propulsion systems which we have been using now, right? So what do you mean by this propeller? What is this propeller? So the propeller is nothing but a fan, right? A fan kind of thing with wings, so which actually propels, which actually moves, right? So the engine takes air from the surroundings, mixes with fuel, burns the fuel to release the energy in the fuel, and uses the heated gas exhaust to move a piston which is attached to the crankshaft. In the automobile, the shaft is used to turn the wheels of a car. In the airplane, the shaft is connected to the propeller. So obviously, we have discussed. I don't know how many of you are from the engineering background. So if at all you have this mechanics or the chemical engineering class, right? So in that we study about the sorry, not chemical engineering, triple E class. So obviously one of the basic classes most of the branches of engineering have, right? We study about the motors and the generators. So when you talk about the motors and the generators, so obviously the motors are the ones which convert the electrical energy into the mechanical energy, right? So we burn something. Likewise the motor vehicles, they burn the fuel, which actually converts the fuel into the mechanical energy. The mechanical energy is nothing but the rotational velocity, rotational speed, right? So the that particular piston which is actually rotating is being connected to the wheels or whichever the moving object, right? Likewise the trains or whichever the automobile is actually running, it is working on the same principle, right? The same way over here, the fuel which is burning, right, taking up the external air, right, it is actually providing that particular energy for the movement of the shaft, right? That particular shaft is actually connected to the propeller, so which is actually making the propeller move. So what will happen if the propeller move? So if the propeller is actually moving, it is actually creating a different pressure fields. So when a different pressure field is actually being created, so obviously the plane actually moves forward, right? So whatever the force that is being created over here, so the plane is being carried forward. So that is how the propulsion system moves. So this is the propeller, right? This is the propeller. So when the propeller is actually moving, there will be the difference in the pressure. So because of the pressure difference, obviously the flight moves. So how the flight directions are actually changed? The flight directions are actually changed because of the wings. So the wing direction is actually changed. So if at all, this is the wing, right? So if at all the air is actually moving in this direction, so depending upon the direction of the wing, depending upon the direction of the wing, right? So obviously the thrust is actually created at the bottom of the wing to lift the airplane up. To lift the airplane up. This is how the propeller actually works. So when the air is actually moving towards the wings, so depending upon the direction of the wing, the thrust, upward thrust is actually produced, right? That is how the airplane moves using the propeller, right? Using the propeller, right? The next system is the turbine. So next one is the turbine. So here we have the moving turbines. So we call it turbojet as well, right? So the early gas turbine engines worked as much as the rocket engine, created a hot exhaust gas which was passed through the nozzle to produce thrust, right? That means, so we have different turbines which are actually rotating. So from the turbines the air is actually moving in, which is actually being combusted, and from the combusted air is actually moving out of a nozzle, right? So when the move is actually made to move from the nozzle at a very faster rate, so obviously the opposite reaction will be the forward movement, right? If at all from the nozzle the air, whatever the combusted gas is actually moving at a very faster rate, at a maximum velocity, so obviously whatever the reaction that is actually produced is the forward movement. That is how the turbine engine works, or the jet engine works, right? But unlike the rocket engine, which must carry its oxygen for the combustion, the turbine engine gets its oxygen from the surrounding air, right? When you talk about the rockets, so we use the rockets for the space launches, whereas in the space you will not have any atmosphere. So because of the thin atmosphere, you cannot use the atmospheric air for the combustion related purposes. But whereas if at all the vehicle is actually traveling within the atmosphere, so we have the plenty of oxygen, and that particular oxygen will be used for the combustion of the fuel rather than carrying its own oxygen fuel. So the likewise we can see in the GSLV, right? In the GSLV, we use liquid hydrogen as the fuel and liquid oxygen as an oxidizer, right? So oxidized is to be carried by the fuel tank, right? So it has to be carried. So here when it comes to the turbine, so because they move in the atmosphere, so because there is plenty of oxygen available, so obviously it doesn't have to carry any required oxygen, right? So it comes from the surrounding air. That is how the turbine engine works. So we'll see how, right? These are the turbines, right? These are the turbines which are actually rotating, and when the air moves through the turbine, so we have the combustion tank. So here the combustion is actually takes place with the fuel, right? So after the combustion, it is actually made to pass through the nozzle with a very increased velocity, right? That is how the turbojet works. So this is how it actually works. This is the movement of the air. This is the movement of the air. This is where the combustion works. This is the thrust. So for every action there is equal and opposite reaction. The plane or whatever the object that is present, that actually moves forward, right? That is the working principles of the turbojet. This is the turbojet. These are the different parts. Nacelle, which is the external covering which holds all the turbines together. The fan, low pressure compressor. So here the whatever the pressure that was created, that was reduced, and this is the high pressure compressor. So the pressure is actually increased over here. And finally the combustion chamber, right? This is the combustion chamber where the ignition actually happens, and the high pressure turbine, right? This is the high pressure turbine, so which actually increases the velocity, which increases the thrust, and the core nozzle and the fan nozzle, which actually makes the exhaust move away through the nozzle. So whatever the force which was actually produced over here, the reaction will be the forward movement of the object, right? This is how the turbojet functions, right? The thrust is produced by passing the hot exhaust from the combustion of the fuel through the nozzle. So we already know that the nozzle accelerates the flow and the reaction to this acceleration produces thrust. Right? So whatever the force that was produced by the movement of the combustion from the movement of the hot exhaust, so obviously the reaction will be the acceleration. Reaction will be the acceleration. So when we use the liquid fuel, so controlling the nozzle, the controlling the amount of fuel that actually amount of the exhaust that passes through the nozzle, you can increase or decrease the velocity of that particular object, right? If at all the thrust, if at all the more exhaust is being passed out, if at all the more exhaust is passed out, so obviously the acceleration will be more. If at all you control the nozzle in such a way that the less exhaust is actually being passed out from the nozzle, so obviously the the slower it moves. So in that way we can actually control the maneuver of that particular object using the liquid propellants. To maintain the flow through the nozzle, the combustion must occur at the pressure that is higher than the pressure at the nozzle exists, right? So the combustion must occur at the pressure that is higher than the pressure at the nozzle exists. So what does that mean? So we know the pressure, the air moves from the higher pressure area to the low pressure area, right? So if at all you want to move this exhaust from the nozzles, obviously you have to maintain the higher pressure before the nozzle so that it will actually move through the lower pressure area and pass through the nozzle. So what at the combustion must always occur at a pressure higher than that of the pressure at the nozzle, right? So the next one, the very important one, is the ramjet. So ram means ramming, right? So jet, so obviously it works on the same principle of jet engine. It works on the same principles of the jet engine. This is the same principle which actually it works, but something is different over here, which is ramming. So what do you mean by ramming? So here in the ramjet, the high pressure is produced by ramming external air into the combustor using a forward speed of the vehicle. This is more important. So what we are actually making, instead of instead of using the turbines over here, we are actually, instead of making the air move through the turbines, we actually, instead of actually making the air forced into the vehicle using the turbines, here we are using the speed of a vehicle to make sure the air actually flows into the engine chamber, right? The high pressure is actually produced by external air. So here the pressure is actually produced by the equipment over here, right? We are actually compressing it so that the pressure actually increases over here. So instead of that, here the pressure is actually enhanced, the pressure is actually increased using the velocity of that particular vehicle. So when you talk about the ramjet, which of the vehicles use the ramjet engine? So obviously the vehicles which are actually the objects which are actually moving at the supersonic speed, the vehicles moving at the supersonic speed uses the ramjet engine, right? So what do you mean by supersonic? Supersonic is nothing but the velocity. If the velocity is greater than the speed of a sound, we call it supersonic, right? We measure that in terms of the Mach, M-A-C-H, Mach, right? So one Mach is nothing but, so the velocity of two objects are same. One Mach is nothing but the speed of a sound. If at all something is greater than one Mach, it means that it is supersonic, right? If at all it is greater than 5 Mach, it is known as hypersonic, right? Supersonic and hypersonic, right? If at all it is greater than 5 Mach, right? Supersonic vehicles or supersonic objects use the ramjet engine. Why? Because in the supersonic speeds, obviously the air flows at a very faster rate. The air flows into the chamber at a very faster rate. So obviously you do not require any of the turbines to make sure the pressure actually increases over there, to increase the pressure in the combustion chamber, right? So that we use the ramjet engine. So here, the like we discussed, like we discussed, the mass is an important factor. Like we discussed, mass is an important factor here, because you do not require any turbines. So obviously here scramjet engine doesn't require any external material, right? So obviously it reduces the weight of a particular object. which increases the velocity, which makes the vehicle move at a very faster rate. The external aid that is brought into the propulsion systems becomes the working fluid, much like the turbojet engine, right? So the external aid that is brought into the propulsion systems becomes the working fluid. The same way in the turbojet engine, where it uses the external aid for the combustion related purposes. So obviously in the same ramjet engine, the principle is more or less the same, but the only difference is that we do not use the turbines in the ramjet, right? We use the velocity of a particular vehicle to increase the pressure of that particular combustion chamber, right? In the turbojet engine, the high pressure of the combustor is generated by a piece of machinery called the compressor, right? In the turbojet we are using the compressor, whereas in the ramjet we do not use any type of such equipment. So how does this actually present? So obviously we see about the scramjet as well, right? So there is one disadvantage of the scramjet. There is one disadvantage of the scramjet. So even though the vehicle is actually moving at the supersonic speed, so what are the shock waves that were produced because of the supersonic speed? So when a particular object is moving beyond the speed of a sound, it produces shock waves, right? So because of the shock waves, if the speed is enhanced, if the speed is increased, so obviously the efficiency of the ramjet engine falls down. The efficiency of the ramjet engine falls down. Because of that, after after entering into the ramjet engine, the velocity of the air is actually reduced. The velocity of the air is actually reduced to the subsonic speeds, right? The velocity of an air is actually reduced to the subsonic speeds. The supersonic speed is actually used to drive the air into the chamber, into the engine, right? But the supersonic speed will not be used for the combustion related purposes. The air is actually reduced to the subsonic speed and then used for the combustion related purposes, right? So if at all the vehicle is actually moving at a hypersonic speed, so obviously you cannot use the ramjet. The efficiency of the ramjet engine fails, right? For that particular purpose, the scramjet engine actually was designed, right? Nullifying the disadvantages of the ramjet engine. So here, when the object is actually moving above 5 Mach, the ramjet propulsion systems becomes very inefficient because of the shock waves that were produced. So for that particular purpose, the new supersonic combustion ramjet, so the ramjet and the scramjet are not so different. So the scramjet is also a ramjet, but it is a supersonic combustion ramjet. So whatever the air which is actually flowing through the ramjet engine is also moving at a supersonic speed, rather than reducing the velocity to the subsonic speed, right? Rather than reducing the speed into the subsonic speed, so it is also moving at a supersonic velocity, right? Or scramjet solves the problem by performing the combustion supersonically in the burner. So whereas in the ramjet engines, obviously the supersonic speed has to be reduced to the subsonic, right? Supersonic has to be reduced to the subsonic and then the combustion has to take place. Whereas in the scramjet, the at the supersonic speeds itself, you can go for the combustion, right? You can go for the combustion of the fuel, right? That is the difference. That is the principal difference between the scramjet and the ramjet. And there is also one other difference between the scramjet and the ramjet. So a ramjet engine cannot be used when the vehicle is actually moving from the zero velocity to the supersonic velocity, right? So when the vehicle is actually initiating the movement, when the object is actually moving initially, so obviously it cannot use the ramjet engine. Only when the object reaches the supersonic speed, only then it can actually employ the ramjet engine. So we have to use an alternative propulsion system to make sure a vehicle moves till the supersonic speed. So only above 1 Mach you can use the ramjet engine, right? So whereas the scramjet can be used to make the vehicle move from the zero to supersonic as well, right? You do not need another engine over here. So you can use the scramjet engine and force the air to move at a supersonic speed. And when the vehicle reaches the supersonic speed, you do not have to force the engine as well. But when it comes to the ramjet engine, to move an object from a zero velocity to the supersonic velocity, supersonic speed, you have to use an alternative propulsion system rather than that of the ramjet. These are the basic principal differences between the ramjet and the scramjet. These are the shock waves. This is how the shock waves are actually produced, right? This is how the shock waves are produced when the object moves the sound barrier, moves faster than the sound velocity. So it works on the principles of the Doppler's effect. You have to remember for the examination perspective, right? So when an object is actually present over here and it is stationary, so obviously they are equidistant. If at all an object is actually moving, so obviously what will happen? So everything will be piled up over here. If at all an object is actually moving faster than the speed of a sound, so obviously the object will be over here and the shock wave is actually produced behind the vehicle. So that is how the shock waves are actually produced. So the shock waves are produced on the principles of the Doppler's effect. Alright. So this is the turbojet engine. Right. This is the turbojet engine. These are the turbines. This is the compression chamber where the ignition actually happens, and this is the exhaust coming out of the nozzle. Right. So this is the ramjet engine. So you do not require any of this extra equipment, right, over here. So which actually reduces the weight, reduces the mass of the vehicle, which actually increases the thrust as well, and which is efficient for an object to move. Right. This is the ramjet engine, which actually reduces the velocity to the subsonic velocity, which actually reduces the velocity of the air to the subsonic velocity over here, and then the combustion takes place. And this is the scramjet engine, where the supersonic speed itself is actually used for the combustion related purposes. Supersonic combustion ramjet, right? So this is the three pictures of the turbojet, ramjet, and the scramjet, right? This is the differences. And next one, the last but not the least, the rocket, right? In the rocket engine, the fuel and the source of oxygen are called the oxidizer, or mixed and exploded in the combustion chamber. So when it comes to the rocket, because it moves away, moves out of the atmosphere, because it moves out of the atmosphere, obviously it has to carry its own oxygen. It has to carry its own oxygen, and also we use the rockets for the missile technology as well, for the designing of the missiles as well. For that also, they will not take the oxygen from the atmosphere, so they carry their own oxidizer. So oxidizer and the fuel have to be combined together and put into the rocket, right? The combustion produces hot exhaust, which is passed through a nozzle to accelerate the flow and produce thrust, right? So whatever the hot exhaust that is actually produced, it passes through a nozzle, which produces thrust, which produces the forward movement. For a rocket, the accelerated gas or the working fluid is the hot exhaust produced during the combustion. We all know that, right? There are two main categories of the rocket engine: liquid rockets and the solid rockets, right? So based on the propellant which we use, right, the solid propellant which we use and the liquid propellant which we use, and both of them have the advantages and the disadvantages. I will be talking about that in the next class, right? So the solid rocket, solid propellant, and the liquid propellant, and we use, if at all we use the solid and the liquid together, we call it the hybrid, right? And also sometimes we use the cryogenic engine as well for the launches, right? So for that we use the liquid hydrogen and the liquid oxygen stored at the cryogenic temperatures, right? So there are two main categories of the rocket engine: liquid rockets and the solid rockets. And just for giving you information, the liquid rockets advantage is that you can maneuver the object in whichever they want, in whichever the way you want. So that is the advantage of the liquid rockets. And when it comes to the solid rockets, it is altogether different. So but the solid rockets are more advantageous because you can actually store the missiles and all, right? You can actually store the solid rockets, right? You can stockpile them. In the liquid rocket, the propellants, the fuel, and the oxidizer are stored separately as liquids and are pumped into the combustion chamber of the nozzle where burning occurs. When it comes to the solid propellants, obviously the oxidizer and the fuel has to be combined together, right? They have to be put together. But when it comes to the liquid fuel, so obviously they are put in the different chambers. This is the fuel, this is the oxidizer, and they are connected to the combustion chamber, and the fuel is actually produced. That is the rocket engine, right? This is the rocket engine where the fuel is actually stored over here and oxidized is actually produced over here, and they are combined together, and in the combustion chamber they are combusted which actually creates an exhaust, which actually provides the forward movement, right, which actually provides the enough thrust for an object to move forward. This is the rocket engine, right? So this is it. This is the rocket engine. So for every action there is equal and opposite reaction, right? And different types of solid propellant, liquid propellant, hybrid, and the cryogenic. So we'll talk about these particular propellants, their advantages and the disadvantages in the next class, right? Hope this clears the difference between the scramjet and the ramjet. If at all you have any further queries, please keep in the comments below and I'll reply, right? So, and also if at all you want me to make any video, so if at all you have any query, so obviously put it in the comments below, so I'll make a video on that particular thing as well, right? Hope this clears for you, Ishwar, right? Now I'll be taking a break. Bye. So if at all you want to contact me, you can message me, you can put in the comments below, or you can follow my Telegram group, right? And also you can come and meet me at Abhayam IAS Academy, Vizag. I'm a permanent faculty over there, right? And also you can WhatsApp me on this particular number 738 648 47 49, right? So please do like, share and subscribe. See you. Bye.